When looking at proofs in geometry, it's one of those things you just really have to take your time. Look at the given, look at the proof, look at the diagram, mark up what you need, use your notes as you get started till you're more comfortable. So with this proof, we are given that FL is equal to AT, and we're trying to prove that FA is equal to LT. So the first thing we're going to do is in the first statement, FL is equal to AT, that's given. Once I have it in my proof, I'm actually going to mark it. So FL is equal to AT. Now before I go any further, I want to look at where I'm trying to get. So what am I trying to prove? So if I look at FA, and I'm going to actually do a little marking on my diagram. I'm trying to get that FA is equal to LT. And when I do that, I notice a couple things from the diagram. In looking at those segments, I have FL already is marked, and I have AT is already marked as being congruent, they're equal. Now the other thing that I notice that is always very important, and you can see this in segments and in angles, is this LA in here, this piece right here, that's an overlapping region I like to call it. That is part of two different things, part of FA and it's also part of LT. So I might have to do something with that LA later in my proof. And when I go back to my proof statements, that happens to be my next statement. LA is equal to LA. And if you're looking at your properties from algebra, that is reflexive property. So once I've done that, I'm actually going to mark my diagram with just a little X. That kind of means it's congruent to each other, it's equal to each other. Now, and looking at the next piece, number 3 says FL plus LA is equal to AT plus LA. So I have to figure out, how did I get there? Now, when we're looking at proofs, you're going to get your information, your reasons from a few spots, either from something from the diagram or something from the steps before it. So in this case, my reason's going to come from the steps before it. So I'm going to use the reasons from the statements, from step 1 and from step 2. And I realize that I have two equality statements, and so they're balanced. Each of them is balanced. If I take the one side and I add them, that gives me my first statement right here. And if I take my other side and add those, that's going to give me my second statement right there. So because I'm adding things together, and I'm still keeping my equation balanced, that's called the addition property of equality. I took two statements that were equal, I added the pieces together, I still kept it balanced, so I have addition property of equality. So in number 4, I have FL plus LA is equal to FA, and LA plus AT is equal to LT. Now sometimes you'll see these are actually two different statements. Here's the first statement and here's the second statement. A lot of times you see them written like that in one step as one statement because their reason is the same. So if I look at my diagram, I notice that FL plus LA is equal to FA. So I have two smalls. Here's my small piece from here to here. Here's another small piece from here to here, and then my big piece FA. So two small segments equal the big segment. The same thing with LA and AT. So I have LA, and LA is here, and AT is also there. So when I add those together, I get LT. So again, two small segments equal the big segment. So that is called the segment addition postulate. Now looking at our last statement, number 5, what I'm trying to prove, I have FA is equal to LT. Well, it looks like I've marked everything up in my diagram, and although I can say that that's true, I don't have anything in my diagram that really helps me. So again, I'm going to go above and look at my previous statements. So if I look at number 3, I have FL plus LA is equal to AT plus LA, and I look at number 4, I have that again. So for instance, I have FL plus LA, and I have that here. And then I have AT plus is equal to AT and LA, which I have it here. So if those two things I circled in yellow and green are equal to each other, then their other pieces are also going to be equal. That's the same as what I have circled in green, right? We're saying that two small pieces equal the big piece. Same thing here. So if I bring that down there, what I did was I actually substituted, I combined, I moved things around in number 3 and 4, I replaced. So when I do all of those things, it doesn't matter how you say it, I use substitution, property of equality. Now another way this video can help you is if you start from the beginning, go back to the start of this proof and pause it, see if you can do the proof yourself. That's a great way to practice. And then you can play it to see if your steps match up with my step.